One electrical service and panel are sufficient for the described building. The National Electrical Code Section 230.2 addresses the requirements for multiple services. The code specifies conditions under which two or more services are required. These conditions relate to load capacity, load division, and multiple buildings. Firstly, if the calculated load exceeds the capacity of a single service, then multiple services are required. Secondly, if the load is divided between two or more service points on the same premises, multiple services are required. Thirdly, if two or more buildings are supplied from the same service, multiple services are required. In the given scenario, the calculated load is 400 amps. This load must be within the capacity of the selected single-service equipment. If the equipment is adequately sized to handle 400 amps, this condition for requiring multiple services is not met. Furthermore, the load is not divided between multiple service points. The description indicates a single service point for the building. Finally, only one building is involved in the scenario. Therefore, the multiple building condition for requiring multiple services is not met. Given these factors, a single electrical service is permissible. When considering the capacity of a single service, several factors must be taken into account. These include the ampacity of the service entrance conductors, the rating of the overcurrent protection device, and the ampacity of the service disconnect. The service entrance conductors must have an ampacity sufficient to carry the calculated load. The overcurrent protection device, typically a circuit breaker or fuses, must be rated to protect the service entrance conductors. The service disconnect must be rated to interrupt the available fault current. The National Electrical Code provides guidance on calculating electrical loads and selecting appropriate service equipment. Article 220 covers the calculation of branch circuit, feeder, and service loads. Article 230 covers services. Article 240 covers overcurrent protection. Article 250 covers grounding and bonding. To determine the calculated load, the demand factors specified in Article 220 should be applied. Demand factors account for the fact that not all loads will be operating simultaneously at their full rated value. Different types of loads have different demand factors. For example, lighting loads typically have a lower demand factor than motor loads. Continuous loads, which operate for 3 hours or more, are required to be multiplied by 125%. After calculating the total load, the service entrance conductors can be sized using the ampacity tables in Article 310. These tables provide the allowable ampacities for different types of conductors based on their insulation type and installation conditions. The overcurrent protection device must be sized to protect the service entrance conductors. The National Electrical Code Section 240.4 specifies the rules for overcurrent protection. In general, the overcurrent protection device should not exceed the ampacity of the conductors it protects. Service disconnect must be rated to interrupt the available fault current at the service location. The available fault current is the maximum amount of current that could flow during a short circuit. This value can be obtained from the local utility company. The service disconnect must have an interrupting rating equal to or greater than the available fault current. Grounding and bonding are essential for electrical safety. The National Electrical Code Article 250 provides detailed requirements for grounding and bonding. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This helps to trip the overcurrent protection device and prevent electrical shock. Bonding is the connection of all metal parts to form a continuous electrical path. This helps to equalize the voltage potential between metal parts and reduce the risk of electrical shock. In the described scenario, the electrical service must be properly grounded and bonded in accordance with the National Electrical Code Article 250. This includes grounding the service neutral, bonding the metal enclosure of the service equipment, and bonding any metal water pipes or gas pipes that enter the building. In summary, a single electrical service is adequate for the described building provided that the calculated load is within the capacity of the service equipment, the load is not divided between multiple service points, and only one building is involved. The service equipment must be properly sized, protected, grounded, and bonded in accordance with the National Electrical Code. Before performing any electrical work, it is essential to consult with a qualified electrician and obtain any necessary permits. Ignoring the National Electrical Code and other applicable codes can result in dangerous conditions that could lead to fire, electrical shock, or other hazards. The National Electrical Code is updated every 3 years, so it is important to use the latest edition. The National Electrical Code is a comprehensive document that covers a wide range of electrical topics. It is essential for anyone involved in the design, installation, or maintenance of electrical systems to be familiar with the code. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work. The safe and proper installation of electrical systems is crucial for protecting people and property.